Okay. Hi, everyone. Thank you all for being here today. My name is Madeline Kennelly. I'm the president of Oxfam at SU, and we are hosting this panel in celebration of Earth Day. For those of you who aren't familiar with Oxfam, it's an international relief and development organization that works to create lasting solutions to poverty and injustices worldwide. Through their work in more than 90 countries, Oxfam has campaigned to raise awareness of the unequal effects of climate change and urge global leaders to take action. Their work includes supporting small-scale farmers, working to enhance international climate cooperation, and calling for more sustainable energy systems, and much more. This year's theme for Earth Day is Restore Our Earth, which rejects the idea that mitigation and adaptation are the only ways to address climate change and focuses instead on natural processes, emerging green technologies, and creative solutions. It is our goal through this panel to educate our attendees on how climate change is affecting our planet and inform them of innovative solutions and environmental policy that will define a more sustainable future. So without further ado, I'd like to invite our panelists to introduce themselves and share a little bit of their experience with climate change in their respective fields.
Tom, go ahead.
Okay, hi everybody. My name is Tom Perot, and thank you so much for attending tonight. I'm a professor and also the chair of the Department of Geography and the Environment, and I teach classes here at SU in environment and society, in environmental justice, in mountain geography, and in food geography as well. And but my research is mostly focused in the Andean region in South America. I've done research in the Amazon basin in Ecuador, and I've done work in the Bolivian Andes. And I would say my kind of most recent experience doing research on looking at climate change was looking at Lake Poopó, which is in the Bolivian Andes, which dried up a few years ago. And so what I had a project which I was working on just before the pandemic, and actually ended up having to stop a trip. I was in Peru and I had to turn around and come back home last March of 2020. But I was on my way to do some follow-up research in that area. And so I was looking at the effects of climate change in combination with urbanization and water contamination for indigenous communities that live on that lake. So got one paper that came out on that, and I'm hoping to get back to that once it's okay to travel again. Doug.
All right, so thank you for having us here tonight. I'm Sherry Abbott. I'm the University Professor of Sustainability Science and Policy. I just, in light of today's event, I am wearing you can't see it, but I'm wearing the Swatch Earth Day, it's the Earth Summit from 1992. It's the official watch from the sustainable, the Environment and Development meeting at which the UN Framework Convention for Climate Change was authored, and as well as the Biodiversity Treaty. And so I wear this today because for Earth Day, when we're talking about restoring the Earth and your interests in Oxfam and poverty reduction, is that solutions to climate change have to be set in the context of sustainability. That is, thinking about the environment, human development and growth, and social inclusion, and all of the things that are currently on the agenda, and dealing with the pandemic, and dealing with economic recovery, and dealing with the climate challenge. And so my discipline of sustainability science is totally aligned with that agenda. And the idea of sustainability science is that we apply the knowledge to the actions that are necessary to improve our prospects for achieving sustainability in these, whatever you want to call, the three pillars of environment, economics, and society. And so that the discipline is hugely important in terms of taking a systems approach and trying to understand not only the dynamics of social, human and nature interactions, but trying to come up with some suggestions for solutions that will help move us in the direction for really not only understanding the integration of these really critical parts of our relationship with the earth and with each other, but also turning that understanding into actionable policies and other activities that are going to move us towards some success over the long term. And so we're really thinking about the near term, the long term, and how all of these things play together. And so I've spent my life in government and academia and nonprofits and in science organizations, working for foundations, and seeing these things from all these different perspectives. And I can say that, it's a hugely important challenge, and we have a lot of knowledge to apply, but we have to do it in a way that is integrated and, focused really on solutions.
First, thanks, Madeline, Alexis, Melissa, and Ethan for getting us together. Really happy to be invited to this. I'm Doug Frank. I'm a professor of biology. I'm the director of our environmental science track in biology. And I teach ecosystem ecology with a big emphasis on climate change, on the science of climate change. And the most fun teaching I do actually is at the graduate level, teaching a course with Peter Wilcoxon, Sarah Prawley, and David Dreesen. It's a very multidisciplinary course on looking at climate change, or as David would call it, climate disruption, from a variety of angles, from the social, economic, legal, and scientific perspectives. And that's really been a lot of fun. So my research passion really is grasslands. I'm what we call a biogeochemist. So I look at the flow of energy, CO2, carbon, and nutrients through terrestrial ecosystems. I've been working in Yellowstone for over 30 years, trying to tease out how elk and bison influence plant and soil processes, and how climate combined with grazing in Yellowstone affect the flows of CO2 in, since photosynthesis draws CO2 out of the atmosphere into the plants and eventually the soil and out of ecosystems. So my work is really related to the function of terrestrial ecosystems and how climate and global warming are influencing those processes. I think I'll turn it over to Madeline, I guess, for the first question.
Yeah, thank you, guys. So we're gonna be heading into our prepared questions portion of the evening. So I'll pose a question and you guys can answer as you choose. So our first question is, how does your field contribute to solutions for climate change?
I'll leave that up to my colleagues, because I've already tried to answer that question in my introduction.
Well, Tom, do you want to take the first crack at that?
Sure, I can do that. I think so. I'm a geographer by training. I actually have my first degree, my bachelor's, is in biology with an emphasis in ecology, but then I moved over to geography because it allowed me to look a little bit more easily at social processes and the relationship between society and environment. So I would say there are two things that geography as a field contributes to solutions for climate change, and I would say also analysis. I mean, I think in order to have solutions, you have to understand the problem that you're dealing with. And so I would say a couple things. One is sort of an analytical approach, and one is a set of tools. So one, the analytical approach is at the core of geography is an understanding that environment or natural systems and social systems are interrelated, that they can't really be separated, that we have to look at environment and society together as integrated and as mutually productive, right? That people are influenced by their environment, the environment are influenced by people, and this is true virtually everywhere. And so looking at those things sort of together at multiple scales from the very, very local to the global, I think is one of the contributions that geographers have made. And then the set of tools, I would say, are around mapping. So GIS, Geographic Information Systems, remote sensing. If you've ever been on Google Earth, if you've ever looked at remotely sensed images that are produced by NASA or NOAA, those are tools that geographers use. And you can take classes in my department on remote sensing, on geographic information systems, and learn how to map and analyze environmental and social processes. And those tools have been, since they were developed initially, like maybe close to 30 years ago now, they have evolved enormously and have had an enormous impact on our ability to view and analyze Earth system processes. And they're used obviously not just in geography, but lots of biologists, lots of earth scientists, lots of atmospheric scientists, lots of policymakers, even historians use GIS to map and analyze spatial processes. So I'd say those are things that geography contribute to analysis and climate solutions.
Yeah, and biologists are interested in the natural system that Tom was talking about, and trying to understand the flow of carbon dioxide, which is our major greenhouse, not the only, but the major greenhouse gas, in and out of terrestrial and marine systems, trying to understand how an increase in atmospheric CO2 concentrations will affect those processes. For example, we're enriching the atmosphere in CO2, and actually CO2 is a resource for plant photosynthesis. So that's stimulating the rate of photosynthesis and the rate at which CO2 is being drawn out of the atmosphere. And but however, the warming end of climate change is facilitating the loss of CO2 out of the soil. So as we change the climate, as we change our environment, these flows are also changing. And it's our charge to really try and better understand how the changing environment is going to feed back on atmospheric CO2 and then either increase. We think there's going to be a positive feedback, so that will lead to an increase in climate change and global warming. The tools, one of the tools that Tom kind of alluded to, I think, was modeling. So an important tool that biologists and atmospheric scientists, all the STEM people, scientists that are contributing to our understanding of flows, ecosystem processes, terrestrial and marine biosphere processes, and how they're changing due to climate change. A lot of that information is being used to develop and improve global climate models, Earth system models, and we use those Earth system models to try and understand the influence that human activity has had on global warming. Ethan is giving me this friendly reminder that I'm at 2 minutes, so I will leave it at that. Boy, that goes fast.
Let's go fast.
I will leave it at that. So Madeline, it's back to you. Oh no, I'm sorry, Sherry.
Well, and the only thing I would add is, in sustainability science is really is more like health sciences and agricultural sciences, in the sense that it's focused on on the challenge, on the problem it's aiming to solve, rather than the specific discipline that is brought to bear. And it really is a collection, relies on all these different disciplines to be able to come up with a broader understanding of the challenges of this intersection of society and the environment and the economy, and in ways that help inform the kinds of processes that are undergirding our decision making and the kinds of solutions that we need to address.
Thank you. Okay, so